want to do it one more time. All right, so take a look at number 5 in your notes. You have triangle ABC. And it says we're going to continuously rotate it around BC. We're going to rotate it around BC. And yesterday we showed, I even had a visual up here. We take BC, we wrap that sucker, keep going and going and going. We know it's going to form a cone. But look at my 4 choices. They're all cones. So I can't even eliminate anything yet. I'm going to rotate it around BC. Continuously rotate it around BC. So can everyone get a visual in your mind what that cone's going to look like? Because I'm about to eliminate 2 of these choices up here. All right, everyone all right on what this cone's going to look like? Because I am going to eliminate this choice here, choice 1. Definitely won't be looking like that. And I'm going to also eliminate choice 2. That's what the cone would look like if I rotated around AC. All right, but rotating it around CB, it's going to be looking a little wider like 3 and 4 are. Now the question is, all right, because these both have a height of 3, and I get where they get that. Everyone see where they're getting that 3 from? Right there. That's a distance of 3. Now the question is the diameter of the full thing going to be 10 or 5 here? So I could choose between 3 and 4. Discuss it in your group. Go ahead. We'll get back to you in a second. Which one is it going to be here? As I rotate it around BC, which cone is it going to look like? We're going around BC, continuously rotated about BC. All right, any group confident? What it's going to look like? Yep, what do you guys have?
3.
Choice 3, yep. Here's why it's going to be 10 versus 5. Take a look. And right now, it's 5. And remember, it's going to get rotated on the other side too, because I keep going and going. So it's going to be another 5 when I rotate it on the other side for a total of 10. All right, everyone's good? All right, just want to make sure we go over another one of those because you may see those again. And the other one I want to do with you is number 6. This is another rotation question, but something we didn't cover yesterday, so I just want to touch on it now. We got a polygon up here. Anybody name this polygon? Pentagon, 5 sides. Yep, this is a pentagon. Which angle of rotation would carry it onto itself? All right, first thing I got to talk about. What's it mean to carry it onto itself? Everyone see that pentagon I gave you? How many degrees can I rotate it so I get that same pentagon back? Same looking pentagon in that position. All right, not, I don't want that. All right, what I want back is that same looking pentagon. Easy answer would be, let's just rotate it all the way around, which would be how many degrees? 360, right? That would be the easy answer. Just rotate it all the way around, you get it back. True. Not a choice. 360 would be a good answer, but it's not a choice. So what other degree measure could I rotate it and still get that same looking pentagon back? Well, let me try something out here. Does everyone agree if I go rotate it from this vertice to this vertice, I'll get that same looking pentagon back? If you don't believe me, here you go. Let me rotate it. Ready? I'm going to go put that vertice over here now. I get my pentagon back, don't I? Right? I get my pentagon. Well, how many degrees did I just rotate then? Because we just said if you go from this vertice to this vertice, I don't know how many degrees that is, but I'm going to get that same pentagon back. Can anybody help me? How can I figure out how many degrees I just rotated to go from one vertice to the next? Oh, we got some picking up calcs. Oh, well, all right. What are you doing in your calc there, Drew? Other than typing your name in. What do you got? Kid thinks he can text people there. What were you trying? Seriously.
I don't know. Just typing numbers in here.
What numbers were you typing in? You might be right.
I was doing the 180 times 5 minus 2.
All right. Close. You're going on the inside. I'm actually going on the outside, though. All right, we just talked. When I go all the way around, how many degrees did I go? 360, right? And how many turns would it take me to go all the way around? How many sides this is, or how many vertices does this bad boy have? 5, right? So if I take 360 divided by 5, go ahead. 360 divided by 5, that gives me. So every time I go vertice to vertice, I'm going 72 degrees. So every time I turn this figure 72 degrees, I get the pentagon back. Is 72 an answer? Okay, so what can I keep doing then? Well, let's rotate it again. 72 degrees. Where am I now? 144. Oh, still not a choice. Keep doing what? Bless you. Keep rotating it 72 degrees. Every time you rotate this pentagon 72 degrees, you're going to get the original one back at you, or the one that looks like the original. Carry it onto itself. So keep going. 144, another 72.
260.
All right, there you go. There's my choice. All right, so every time you go vertice to vertice, rotate it one on top of the other, you'll get that same pentagon back. Now look, I change it to a hexagon. Okay, now that changes to 6. I give you an octagon, that changes to 8. All right, but that's what that means. Carry it onto itself. How many degrees can you rotate in and get this pentagon back looking figure? The same looking pentagon back. We okay here? It's just a matter of how many vertices I have. Okay, put away your packet, or just at least close it up for me. You guys can finish that after we're doing this next activity. All right, close it up. Now we're going to figure out how much do I know and don't know going into the quiz tomorrow. Everyone's going to get a scrap sheet of graph paper from me right now to use for this activity. This is not a group activity. This is a solo activity. Again, it's going to show you how much you know and how much you need to know by tomorrow. All right, so here's the activity. Up on the board here in a second, I have 6 different transformations I want you to perform. All right, 6 different transformations. Hopefully, you know your notation, so you know what I'm asking. All right, because I'm not going to help you out there. All right, so hopefully you know 1, 2, 3, 4, 5, 6, what all the notation means and what I'm asking. I'm going to call on 2 people right now. Those 2 people are going to give me a random point. And on that random point, you're going to perform these 6 transformations. All right, so that is why you have the scrap sheet of graph paper to help you out there. All right, so let's, I'll go over the directions a little more clearly once I have the points, but big class decision here, big class decision. All right, let's start this off here. Finley, any random point, please. How about you just change that other number there, please? 4-2, all right. So what's going to happen right now is everyone's going to take 4-2 and perform these 6 transformations on 4-2. You always go back to the original and do it. And then after you're done doing that, we're going to do it all over again, but with, Simon?
6-4.
How about I do -6-4? Get a little negative action in there. All right, good. All right, so does everyone see what the task is? Because you're going to have about 15, 20, no, not 20, but probably 15 minutes to do this. All right, so use your graph paper. Also, a problem we ran into first period, because I'm going to call on 12 different people. All right, I'm not going to call on the same people again. I'm going to call on 12 different people to give me the answer. Make sure you know where your answer is. Somehow have it labeled so when I get up to the first or second one, you know where that point is. All right, because a couple people in first period are like, where did I put that point? Where is it? Where is it? Make sure you know which point it is so when you get called on, you can give it to me like that. All right, so go ahead. Perform these 6. 1, 2, 3, 4, 5, 6. And I'll do the same because I don't have an answer key for that one. For you guys in the back here, that capital R has a subscript of -90, everyone. That's a -90 as its subscript for capital R. And this is just a sniff, just a taste of what I could have for tomorrow. All right, just a sniff. Let's see. You see there, Jonathan? You see there? All right. We got one. Remember, if you don't know what a line looks like, graph it. You're unsure if it's horizontal or vertical. Be asking 12 different people here. What do you say? Should we boo and clap if they get it right or wrong? Huh? Or too harsh? Too harsh. We don't have many thick skin in here, so don't need people tearing up if they get booed.
Use the bathroom.
Sure. Don't worry, you get called on. We're saving it for you. Kids getting nervous. Bless you. For what? Reflections? So now we're going to go down 3 tests and quizzes tomorrow? Is that the plan? We'll talk about it after class because it's getting a little backed up now. Give you another minute here. All right, ready to roll. Let's do this. Here we go. First one, that is notation for a reflection over the x-axis. Reflection over the x-axis. Where is 4, 2 going? Where is 4, 2 going? All right, Jonathan got that first one. Where's 4, 2 going, big dog? 4, -2. Good start. Good start. That's going to 4, -2. Good. Next one, reflection over x equals 3. That is a vertical line. And no, I don't want any excuses tomorrow. You can graph it. If you're unsure if it's horizontal or vertical, you can go to Grapher on your NumWorks calculator, put x equals 3 and see it's a vertical line. And where would 4, 2 end up after a reflection in that one? Here we go. Where's my one? Cormac, there you go. 2, 2. Good job. Not as nervous as I thought you were. Good. 2, 2. Next one. This is vector notation, which means it's a translation. Left 2, up 3. Left 2, up 3. All right. Left 2, up 3. Where am I going? Vinny, where am I going here? 2, 5. Yes. And I don't know if anybody has picked up. You don't have to go count left 2, up 3 on the graph. You could subtract 2 from your x coordinate and add 3 to your y. That's the other way of doing it too. You don't have to count, but if you want, keep going. Oh boy. Rotation -90, which means which direction? Clockwise. So we should have been turning our papers to your right. Okay, to the right, clockwise, just like our clock goes up on the wall over there. And it should have been some combination of 4 and 2, right? Nobody should be giving me 5, 8, 6, 7, 1. All right, should be some combination of the 4 and 2 there. Here we go. Already went. Lucky guy. Oh, Finley, here we go. What do we have here? Hey, there we go. 2, -4. Perfect. Maybe you got, if you have some other combination, maybe you turned it to the left instead of to clockwise to the right. All right, capital T for translation. Now we're going left 3, down 4. Left 3, down 4. Where am I going to end up here? Oh, Stellan, where are we going to end up? 1, -2. Again, you could have subtracted 3 from your x and subtract 4 from your y's instead of counting. And then finally, a reflection over y equals x. Do we know the rule? We got to know that rule tomorrow. All right, along with y equals x. But this is y equals -x. So what did 4, 2 turn into? 4, Tess, what do you got? What's the rule? Come on. Dig deep. You remember the rule for y equals x? Y equals x. Flip them, but this is y equals -x. So not only do I flip them, but go ahead for me. All right, there you go. You'll know it tomorrow too. -2, -4. Everyone's good. Going. Because I'm going to do it all over again with 6 new people. All right, -6, 4. Hopefully that negative didn't throw you off. -6, 4. Reflection in the x-axis, Lauren. -6, -4. Perfect. Do this in a different color so everybody can see. All right, what about the vertical line, x equals 3? Vertical line, x equals 3. Where do I end up? This was a big one. You had to count a while, huh? Simon, go ahead. Did you already go?
Wait, say it.
Oh, boy, this kid. Take a -6, 4, reflecting it over. 12? Look at you. There you go. Good job, boss. 12, 4. Translation, left 2, up 3. Left 2, up 3. Where are we going? Henry, back there. Yeah, -8, 7. Oh, rotation, clockwise. 1/4 turn to your right. Or memorize the rule. If anybody memorizes rules, this is the same as a rotation of +270. If anybody memorizes the rules instead of turning papers. But either way, let me just make sure I know the answer. Okay. Where's this going to go? Ooh, already up. Vinny's good. Oh, there we go. Dylan, what do you got over there, boss?
4, 6.
4, 6. Yes. If you got something, another combination of 4 and 6, maybe you went to the left again. All right, keep going here. Let's finish off strong. Left 3, down 4. Left 3, down 4. Where do you end up? Oh, there's a new number. 2 zip, Brendan.
-9, 0.
Yep. Guys are on fire. And then let's finish. Y equals -x. We just went over the rule. Oh, you're on fire there, Vinny. 1s. Micaiah, what do you got back there? Switch and change the signs. Switch and change the signs. Again, that's just a little taste of what I could ask for tomorrow. I could ask for a rotation in the positive direction tomorrow. Y equals 3. Y equals x. All right, just a little sniff of what you're getting tomorrow. All right, last thing I need to go over with you before I let you go and finish the assignment. Make sure when you're doing translations, you are aware of the different ways to write it. I just gave you this one on the quick pre-quiz here. What type of notation is that? That's called vector notation. Easily tomorrow, I could ask to leave your answer in function notation. So quick review. Must be a reason why I'm taking time to review it, by the way. Function notation. Always start off with x comma y in parentheses. It's gotta. Then with your arrow, tell me what you're doing with it. So if I do this one in function notation, I'm moving my x's left 2 and my y's up 3. That's vector. This by itself doesn't cut it. That's not function notation. You have to have the x comma y implies and then write your rule. All right, so be ready to leave it in both tomorrow, both notations. You got the rest of the time to work on day 4. All right, answers are in on Classroom. All right, answers up on Classroom. Stop by today if you have any